In this video, we are going to formally start to talk about limits, specifically at points of discontinuity, but just limits in general. So our example says, use the graphs provided below to answer the follow-up questions. So here I have graph A, it's a rational function. Let's just review some of our key features for a second here. This is my horizontal asymptote. This is my vertical asymptote. I would have a 0 here at x equals -2. I have a hole here. So it says the graph has a hole at x equals 1. So they want to know the limit as x approaches 1 with this negative here. So this means from the left. So if I approach 1, which is right here at this hole, right here, from the left. So here, a limit is really a height or a y value. So the whole of 1, 3, the limit as x approaches 1 from the left is at 3. So just a limit is a height or a y value. The next says the limit as x approaches 1 with this plus sign, and that means from the right. So if I approach from the right, it equals 3. And now they just want to know the limit as x approaches 1. There's nothing here, so this is like the overall limit, which is like not a real math term, but that's just what I'll use. And since these two are equal, that means that my limit is 3. Now, this function is discontinuous at x equals 1. It is known as a removable discontinuity. Okay, so a hole is a removable discontinuity. Remember, it's discontinuous, so it needs to be excluded from the domain. So if I were to write the domain of this function, 1 would be excluded. Let's take a look at graph B. So graph B, they're going to focus now on my vertical asymptote. So I have a vertical asymptote at x equals 1 right here. So this is my vertical asymptote. So I want to know the limit as x approaches 1 with negative. So remember, that's x approaches 1 from the left. So as x approaches 1 from the left, I'm going to negative infinity. The next one is as x approaches 1 from the right, trace my graph, I'm going to positive infinity. So now my overall limit, these two are not equal, so my overall limit is DNE, also known as does not exist. And this is called an infinite discontinuity. So an vertical asymptote is an infinite discontinuity, which remember means it must be excluded from the domain. So sometimes the values of a function f can approach different values as x approaches the number c from opposite sides. When this happens, the limit of f as x approaches c from the left is the left-hand limit, and the limit of f as x approaches c from the right is the right-hand limit. So this negative is left hand, this positive is right hand. In order for a limit to exist, both the left and right sides must be the same. So this is what that means in notation. So what if the limit as x approaches c from the left of f of x is equal to the limit as x approaches c from the right? That means the limit as x approaches c for f of x exists. What if they do not equal? That means the limit as x approaches c for f of x does not exist. Let's take a look at an example. So remember, this is just my overall limit. So I have to approach x equals 1 from the left. So the limit as x approaches 1 from the left for each of x goes to negative infinity. And then as I approach from the right, so the limit as x approaches 1 from the right for each of x goes to positive infinity. So since those two values do not equal each other, my overall limit does not exist. I'm going to approach a different value now, so I'm just going to erase these. So I have the limit as x approaches negative 1. So the limit as x approaches negative 1 from the left is right here, is 0. And now I have the limit as x approaches negative 1 from the right is also 0. So since these two equal each other, that means that my overall limit is 0. Just going to erase once again. And now I'm approaching 3. So I have the limit as x approaches 3 from the left for each of x is equal to 2. And now I have the limit as x approaches 3 from the right is also 2. So since those two equal each other, my overall limit exists and is 2.